Welcome back. Today we've got an explainer that is honestly completely unlike anything we've covered before. We're going to be exploring this absolutely fascinating theoretical framework, and get this, it builds incredibly complex systems theory and quantum fluid dynamics entirely from the perspective of a butcher. I know, right? It's this wild collision of physical, blue-collar trade intuition and high-level physics. Okay, let's dive right into this. The creator of this framework, Kyle Roberts, frames the entire theory around this really striking analogy. He says, a straight line is just a curve that has been pressured into submission. Think about that for a second. He's suggesting that our standard mathematical tools might actually be missing the hidden underlying flow of reality simply because we're constantly forcing straight lines onto a universe that's inherently curved and dynamic. So, to wrap our heads around this, we're going to follow a pretty structured journey today. First, we'll look at the butcher's universe. Second, contextual noise resonance. Third, the liquid vacuum model. Fourth, the golden ratio flow. And finally, we'll check out the Project Midnight UV prototype.
All right, starting us off. Section 1, the butcher's universe.
Now, the foundation of this entire theory doesn't start in some sterile laboratory or on a dusty chalkboard. It actually begins on a cutting board. It uses literal physical labor to intuitively map out these massive complex systems. And a core concept here is what he calls the butcher sink. Imagine a literal sink where blood, fat, scraps, water, just the whole shebang is all mixed together. Now, standard academia, they'd usually filter out that dirty data right away to find a clean signal. But the butcher sink approach, it throws all the data in first. It refuses to toss anything out until its relational value has been totally tested. You basically just watch the mess and you observe what relationships naturally emerge. And this brilliantly illustrates why context is literally everything. Think about it. On a standard cut of lean beef, fat is considered waste, right? It's just noise, so you trim it away. But take a high-end cut of Wagyu beef. That exact same fat is a highly valuable signal that dictates the entire quality of the meat. The physical material didn't change one bit. The value placed on it by the observer and the context did. We see the same idea pop up again in what's called the sausage filler analogy. So you could have the exact same machine making the exact same mechanical noises, doing the exact same physical process. But the outcome is going to drastically change based on hidden variables. Things like the care factor, the fatigue, or the intent of the human operating it. Measuring just the physical output or the visible signal, that completely misses the crucial hidden human elements at play in the system. So the crucial point we really need to take away here is that a weak, isolated signal often means absolutely nothing on its own. Hear one weird noise from a machine? You'll probably ignore it. Two noises, maybe you pause. But add a third interacting noise, suddenly you know for a fact that machine is broke, or someone's getting hurt. In this framework, a signal isn't just some static thing you stumble upon, it's an event. It emerges strictly from the interaction of multiple contextual pieces of what we'd usually just call noise. Which brings us to Section 2, contextual noise resonance. This is where things get really cool, because we start guiding these visceral, bloody butcher metaphors straight into formal mathematics and systems theory. The source material maps it out perfectly for us. So dirty data from the butcher's block, that becomes raw, unfiltered input in data science. When noise sings loud, that formally translates to emergent signal amplification. Pressure buildup becomes deviation accumulation, and that residue left on a knife, that's historical state memory. It's actually amazing how physical intuition directly mirrors formal algorithmic vocabulary here. All right, let's keep moving. Section 3, the liquid vacuum model. Now, let's scale this whole thing up to the universe itself. This framework visualizes the cosmos not as just empty space, but as a dynamic, actively flowing fluid. I mean, this is a massive paradigm shift. Standard physics usually treats gravity as this mysterious pulling force coming from a center of mass, right? But the liquid vacuum model proposed in the source material flips that entirely on its head. It visualizes gravity as a liquid push, an external, spherical inward pressure coming from a high viscosity superfluid vacuum. So the universe isn't pulling you down, the vacuum is actually pushing you in. Now, what's really interesting about this slide is the creator's critique of standard measurements. If you try to measure curved, fluid space with a standard straight ruler or tape measure, well, you might find the shortest distance, sure, but you are completely missing the deep viscosity and the complex geometry of the curve itself. You're basically trying to measure a dynamic fluid with a rigid linear tool. It just doesn't work. Which, of course, naturally leads us to ask, if our straight tape is only measuring 3 flat dimensions, Where do the missing fractional dimensions hide? Because according to this entire framework, the universe doesn't operate in clean whole numbers. It operates in fractions and spirals. To explain this, the creator uses a really fun, grounded concept, the beer-pour paradox. Okay, imagine the universe is a glass, being filled with beer. The liquid itself is the unseen vacuum substrate, and the foam and bubbles sitting on top. That's solid matter. But notice, the glass never actually overflows. Why is that? Well, because the energy off-gases through what's called a reciprocal exit flow, or non-local entanglement. Energy doesn't just hit a wall and stop. It continuously flows in and out of the system. It's a really great way to visualize it. Moving right along to section 4, the golden ratio flow. So how exactly does that energy flow? Let's take a look at the formal math proposed to describe this movement. The creator outlines what he calls an omni-push equation. Here are the key forces at play. P total is the total push of the universe. Eta represents the viscosity, or the thickness of the vacuum. Psi is the quantum spine frequency, basically the fundamental vibration. And finally, delta V is the singularity sink, which is like a vortex that creates a vacuum, pulling that liquid fluid right toward it. And all these variables interact within a very, very specific dimensional space, 9.6. That's right, in this model, the universe operates in 9.6 active dimensions. That leaves a crucial 0.4 gap before hitting a solid 10. And that fractional gap, that's the seam where the liquid universe literally breathes in and out, allowing for that reciprocal energy flow we just talked about in the beer-pour paradox. What's amazing is how this completely reframes standard concepts like string theory. Imagine throwing a coin into water. The particle isn't a solid object. It's the coin acting like a spinning propeller as it drops down. So the strings of string theory aren't vibrating rubber bands at all. They're actually the hydrodynamic wakes, the cavitation trails of air bubbles left behind as energy tunnels through this thick, viscous vacuum.
And that brings us to our final segment, Section 5, Project Midnight UV Prototype.
This is where the explainer gets incredibly practical. I mean, how do you actually take 9.6-dimensional quantum fluid math and apply it to hardware? Well, you build a prototype. The source material outlines Project Midnight, which is this wild attempt to repurpose a standard Hyundai Glovebox UV sanitizer into a 9.6-dimensional resonance chamber. The goal is to take that theoretical omni-push equation and physically manifest it into a contained space. Let's move to the next slide and see how this builds out, because the instructions for this vault are highly specific and, honestly, remarkably blue color. First, you line the interior with crinkled aluminum foil. This creates these chaotic, non-Euclidean reflections to bounce light from unpredictable angles. Second, you offset the UV LEDs by exactly 3.6 degrees, and that's to match that fractional dimensional gap we mentioned earlier. Finally, you use midnight purple and hot pink to shift the UV frequency, so the resonance creates this visible, tangible glow. So what's the actual point of all this hacked hardware? Well, the goal is to turn a simple box into a resonant cavity. By using those highly specific angles and frequencies, the prototype attempts to force light energy to loop along a golden ratio spiral. According to the framework's liquid logic, this effectively vibrates the quantum spine of the localized space, rather than just, pointing a static beam of light at an object. Obviously, it's a wildly ambitious leap, going from cutting meat to hacking together quantum resonance chambers. But it all ties back to this incredibly powerful philosophy from the creator. He says, we're calculating the thickness of the truth, not just the length of the lie. I love that. It's a fantastic reminder that when we only use straight tapes to measure our world, we miss the depth, we miss the context, and we completely miss the interacting noise that actually shapes reality. Which leaves us with this final, really provocative thought to chew on. If our reality, matter, strings, and signals, is just the visible bubbles flowing through a vast, unseen, high-viscosity liquid, what else are we missing by trying to measure the universe with a straight tape? I mean, think about how you measure the complex systems in your own life. Are you discarding the noise a little too early? Keep that in mind as you look at the world around you, and as always, keep learning.